In this presentation, we are going to see the concepts of orthogonal cutting and oblique cutting. From this slide, we can see two different pictures. The first picture shows the orthogonal cutting, the second picture shows the oblique cutting. In the first picture, there is orthogonal cutting. Ortho, the name of ortho, that will be straight or perpendicular. Here, on this, the cutting edge of the tool that will be perpendicular to the feed direction. So this type of cutting that will be called as the orthogonal cutting. Here the cutting edge of the tool is perpendicular to the feed direction. Those type of cutting that will be called as the orthogonal cutting. Now you can see the oblique cutting in the second picture. The cutting edge of the tool that will be having some angle of inclination. Here in this picture, this is 60 degree. Some angle of inclination with the feed direction. These type of cuttings are called as oblique cutting. That is, the cutting edge is having acute angle with the feed direction. Those cuttings are called as the oblique cutting. This is the major distinction between the orthogonal cutting and oblique cutting. Again you can observe that from this slide, that is the depth of cut in both the cutting are same. For the same depth of cut, here the cutting edge that is having perpendicular to the feed direction in the orthogonal cutting. For same depth of cut, here the cutting edge is having some angle of inclination with the feed direction. That is called as the oblique cutting. Here for the same depth of cut, the cutting edge, the contact of cutting edge with the work material, that will be very less. For the same depth of cut, the contact of cutting edge with the work material, that will be very high, comparatively high comparing to the orthogonal cutting. Due to this, whatever the cutting force generated, that will be concentrated on the smaller area in the case of orthogonal cutting. Due to this, the tool life that may reduce. In oblique cutting, so due to the angle of inclination of the tool cutting tool edge, the larger area of contact that will be induced in oblique cutting. So whatever the cutting forces that will be generated, that will be distributed to the larger area. Here the cutting edge, that is smaller area and larger area, we have used this term, the smaller and larger area. In another way, the cutting edge contact area, that will be a shear zone, that is the smaller shear zone in the case of orthogonal cutting for the same depth of cut. In the case of oblique cutting, larger shear zone for the same depth of cut. Due to this, what are the cutting forces generated, that will be spread out over the smaller area in the orthogonal cutting. Here in the case of oblique cutting, the cutting forces generated, that will be spread out over the larger area in the case of oblique cutting. So due to this, the smaller area resistance, due to the smaller area resistance, the tool life that will be very less in the case of orthogonal cutting. Here the cutting forces that will be spread out over the larger area, so the tool life is somewhat higher comparing to the orthogonal cutting. So again one more thing, the accumulation of heat that will be concentrated on the smaller area in the case of orthogonal cutting. So once again, due to the accumulation of heat, the tool life that will be reduces. In the case of oblique cutting, the accumulation of heat that will be spread out over the larger area comparing to the orthogonal cutting. So the accumulation of heat that will be spread out over the large area, then the tool life that may increase comparing to the orthogonal cutting. Again, here in the orthogonal cutting, so here the work that will be rotating in the chuck, this is the rotation of work material. So due to this rotation of work material, the provided depth of cut, the work material that comes and having contact with the cutting tool edge and shears over the cutting tool edge, and the chip or slides over the rake surface. So the cutting forces that will be generated in the z direction. This is the cutting force, and one more force due to the feed. There are two forces in the case of orthogonal cutting. One is cutting force that will be directed downwards, that is z direction. Another one is thrust force or axial force. There are two forces. This is the cutting force, this is the thrust force or axial force. There are two forces that will be generated in the orthogonal cutting. But in the case of oblique cutting, the cutting force is same due to the downward force, the cutting tool edge and the work material, the depth of cut work material. Due to this, the only one force that will be generated, the cutting force that will be generated, and another force due to the axial feed. Here the angle of inclination of the cutting edge that is having contact with the work material. So the resultant force that will be generated like this, the resultant force that will be resolved into the axial and the radial force, that is along with the cutting force perpendicular force. One is axial force that will be induced, and another one is radial force. There are three components in the case of oblique cutting. Here in the orthogonal cutting, there are two forces, cutting force and the axial force. In the case of oblique cutting, one is cutting force in z direction, and axial force in x direction, and radial force in the y direction. There are three cutting forces. There are three components of forces that may be considered in the case of oblique cutting. But in the orthogonal cutting, only two, cutting force and thrust force, axial force, thrust force or axial force. Due to the straight cutting edge, in the orthogonal cutting, we can achieve the straight turning surface as well as the sharp corners. But in the case of oblique cutting, we could not achieve the straight and sharp corners. Only the fillet like chamfer corners that will be possible. Again, here in this case, in orthogonal cutting, for the same depth of cut, the lesser amount of material that will be removed, because the contact area is very less, and force generation that will be accumulated in the concentrated area. So the orthogonal cutting that will be used for smaller amount of material removal. But the oblique cutting that will be used for massive material removal rate, because that is having larger area of contact in the cutting edge. So we can add the depth of cut, and for the same amount of force retention in the cutting tool. So the massive material that will be possible in the case of oblique cutting. Here in the orthogonal cutting, minor amount of material removal that will be possible. And in orthogonal cutting, the cutting edge that will be perpendicular to the feed direction. Here the rake surface is also perpendicular. The rake surface is also perpendicular in the case of orthogonal cutting. Rake surface is also perpendicular in the case of orthogonal cutting. So due to this, whatever the material that will be removed, that will be curled over the rake surface. Due to this curling of chip, the accumulation of heat that will be concentrated under the cutting edge as well as the rake surface. So due to this, the tool life again that may reduce, the built-up edge formation that may be the possibility of built-up edge formation that will be there in orthogonal cutting. And due to this accumulation of heat and built-up edge, the surface finish that may affect, the surface finish of the machined surface that may affect in the case of orthogonal cutting. But if you are taking the oblique cutting, due to the angle of inclination of the cutting edge and the surface, rake surface, angle of inclination of the rake surface, whenever the chip that will be slides over the rake surface, that will be deviated from the cutting zone, and that will be curled away from the cutting surface. So the cutting surface, the finished surface, the machined surface, that will be safeguarded in the case of oblique cutting, as well as the accumulation of heat over the rake surface and the cutting edge that will be avoided. So in this case, the tool life that will be increased, as well as surface finish also that will be good. This is the abstract, whatever we have discussed in the pictures, so that will be given in the abstract form as a statements. So we will see the once again the statements, the concepts of orthogonal oblique cutting. The first point, cutting edge is 90-degree orthogonal or perpendicular to the cutting direction, that will be called as the orthogonal cutting. Now the definition of oblique cutting, cutting edge is having acute angle of contact with cutting direction, that will be called as the oblique cutting. For the same depth of cut, the oblique cutting had a larger shear zone, thus forces spread over larger area. Due to the larger shear zone, forces spread over the larger area. In turn, the oblique cutting reduces the accumulation of heat and improves the tool life. Due to the larger shear zone and due to the larger shear zone, here the accumulation of heat that will be very less, reduces the accumulation of heat and improves the tool life. The orthogonal attack makes the chip to curl over the rake surface in short spiral form. But in oblique cutting, the chip flows in sideways in a longer curl. In orthogonal, only two forces, namely cutting force and thrust force, are acting. But in oblique cutting, there are three forces, namely cutting force, thrust force and radial forces are acting. In orthogonal cutting, machining of straight and sharp edges at smaller amount is possible. In oblique cutting, bulk machining is achieved, but cannot give the straight and sharp edges. These are all the pros and cons and distinction between the orthogonal and oblique cutting. Thank you.